Hello kay si sim.com. Ayan, mayroon po tayong isa. Huwag kalimutan mag thumbs up yan. Thumbs up. Din pangita onda kung mag thumbs up. Ayan, first time ko lang talaga. Kaya medyo hindi pa ganong alam. Subok lang po. Ayan, ayan po. Salamat kay sim.com sa tamsak-tamsak-tamsak mo po. Maraming salamat po. Salamat kay sim.com sa tamsak-tamsak-tamsak mo po. Maraming salamat po. Ayan, ayan kay Maki Bundok. Maraming salamat sa tamsak mo, Maki Bundok. Team Banana. Ayan, pasensya na kayo dahil ako po ay first LS ko pa lang po. Ako yung nangangapa pa. Sa hindi pa tayo magkadikit, babalikan ko lang kayo pagkatapos itong pag-live ko po.
Chris Carr specializes in working out how differing gravity affects the way we walk. He's got an amazing device which will let me experience walking anywhere in the solar system without leaving his lab.
So what we have right here, we have the adult version of the baby bouncer. So let's give it a try. Go ahead and step forward just a little bit. And we'll bring this down.
This is a variable gravity treadmill and works by partially supporting my weight to let me walk in non-Earth gravities.
So we're going to take you probably first to close to lunar gravity.
Chris sets the equipment so I weigh what I would on the moon.
Lights on. Picking up some dust. 30 seconds forward. Okay, engine stop.
The moon is the only low-G environment where man has ever walked. So maybe the space pioneers can learn from the Apollo guys.
If you don't mind, you can step on there. And this will just tell us about what we're in.
165.
So somewhere in the low 20s is going to be a good estimate.
Yes, okay. We're ready to go. The load on my legs is now equivalent to walking on the moon.
Here we are at 2 miles per hour. And try jumping a little bit. And there's 2.5 miles per hour.
Right, so it's kind of like running. I can run, but it's the frequency that I'm stepping is much less. It's clear that the basics of mobility change dramatically when we reduce gravity by this much. 3 miles per hour on Earth is walking pace, but that's not the case on the moon. At this speed, it's more efficient for me to run or bounce like this.
At this gravity, in fact, it's going to be more efficient per unit distance for you to run or lope to get somewhere than to walk.
So it's loping.
Loping.
Okay.
It's like a skip, but without changing which foot you're bouncing on. Give it a try if you'd like. Let's try that. Wouldn't mind hopping on there.
Well, the same principles of movement apply when we swap from the 1/6 Earth gravity found on the moon to the 1/3 gravity on Mercury.
Let's try walking. What do you think?
Yeah, I think walking would be all right. Yeah.
Walking's all right? How about jumping?
My feet, when I land, on the moon, they touch almost at the same time, but here, one comes quite a bit after the other.
Okay. And how does it feel in terms of, how much work it is to do?
Okay, this is running. I'm feeling quite light and bouncy, and it doesn't feel that difficult. Right, loping. I'd say running was easier. Loping seemed the most efficient way to get around on the moon, but on Mercury, I'd definitely rather be running. This is an important piece of intelligence for the Mercury pioneers, because in this ultra-harsh place, being able to move around quickly would be a matter of life and death.
As the settlers work in their crater rim habitat, a magnetic storm erupts on the sun. An explosion of deadly radiation is coming their way. Just 10 minutes exposure will be fatal, but the pioneers have chosen their crater well, close to the pole and with steep sides. The radiation passes overhead.
I've picked a base for the crew in an icy crater. They'll be able to survive long-term on the most extreme planet in the solar system. But they aren't here to hide inside their habitat. Mercury is packed with spectacular sights to explore, like the 1,000-mile Calorus Basin. And Discovery scarps 400 miles of spectacular cliffs. But all these sites are off limits, as they're too far from the shelter of the polar region. However, some Mercury scientists think there might be a way to explore anywhere we like.
Another idea is that you could go right on the Terminator.
right at the line between the hot side and the cold side, that might be a place that you could survive for a while.
On one side of Mercury is extreme heat. On the other side, deadly cold. Mercury spins incredibly slowly on its axis. One day on Mercury lasts a staggering 176 Earth days. The result is that pioneers will be exposed to long periods of deep chill, followed by months in the full glare of the sun. But what if there was somewhere between the two extremes? An area where the temperature is just right. This is the twilight zone, where night meets day, and experts have named it the Terminator. I need to discover how wide the comfort zone would be within the Terminator to find out the limits of where my pioneers can survive. I'm on what I suspect will be a very uncomfortable fact-finding mission.
Okay, Basil, so what we're doing now is we're going to experience what happens if you move towards the edges of that thermal comfort zone that you've got on Mercury.
Mike Tipton is an extreme survival specialist. He's got a two-part test planned for me to see what happens when my body gets to the limits of hot and cold. That camera there is looking at my thermal signature before I go in.
Yeah.
And it's all quite bright. That means I'm hot.
It does. If you concentrate particularly on your hands there with the face in between them, and you're controlling your deep body temperature at the moment just by changing the amount of blood that goes to the skin. You're not having to sweat and you're not having to shiver.
Right, to the cold side of Mercury.
To the cold side of Mercury. Here we come.
This room is as cold as a home chest freezer. It doesn't take long for the extremities of my body to start suffering. How cold is my skin now?
Now you've come down from your starting temperature. You're down by about 20 degrees Fahrenheit already.
Now, we've only been in here for 4 minutes and 15 seconds.
Yeah.
And the blood flow to my extremities is being shut down.
Yeah.
5 minutes later, and the Arctic temperatures are really starting to take their toll. Even though I look okay, I'm now losing heat faster than my body can generate it.
Your extremities are becoming cold and they've reached the level where we, for safety reasons, withdraw you from the environment.
It's starting to get painful.
Yeah, let's go.
Okay. I'm now at the cold edge of my survival zone, 36 below. But what about my upper limit? Walking this corridor is a bit like crossing Mercury's Terminator zone. From night to day.
Are you ready to go and experience the hot side of the band? Okay then, Basil, let's get in.
Wow, that is hot.
Okay. Do some light exercise in here.
In here, it's as hot as Death Valley in July, and I can tell you, even light exercise in 120 degrees Fahrenheit isn't fun. Clammy, I'm sweating all over. I'm not sure I can keep this up for much longer. The settlers on the Mercury Terminator, this temperature would be at the very edge of their tolerance levels.
When you get up to deep body temperature of 113 degrees Fahrenheit, the proteins in your body will start to denature. In the same way as when you fry an egg and it gets hot, it goes white. And you're essentially now moving into a situation of hypothermia and hypothermic death. It's time to get you out back into the cool environment outside. Okay, well done.
That sets the upper comfort limit at 122 degrees. And I know that 36 below freezing is my lower limit. So what does this equate to in Mercury's Terminator zone? Because Mercury has no insulating atmosphere, as night falls, the temperature drops incredibly quickly, from 800 to minus 300 Fahrenheit. Jeff Landis has worked out that the human comfort zone is just 30 miles wide. However, Mercury is rotating, so the terminator line is constantly on the move. Earth has a terminator too, but our line moves at 1,000 miles an hour.
Well, Mercury rotates a little bit more slowly than Earth, fortunately. So if you could just chase the Terminator, you'd only have to move about 2 miles an hour to keep up with the sunset. You might be able to make a habitat. Big wheels just keep going around and around so that you always have that solar energy, but you're also always at the area that isn't too hot.
Jeff's genius solution takes advantage of Mercury's sunshine and shade. A huge rolling habitat will stay in the cool zone of the Terminator. Following behind in the sunlight is their power station, a small truck that turns sunlight into electricity. This extraordinary home on wheels can keep going forever, circling the planet every 176 days.
Rolling forwards at 2 miles per hour, the pioneers have traveled miles from their cool crater base. But something's wrong. They are using oxygen far faster than expected. Reserve supplies back at base are more than a week away. In their slow-moving habitat, the pioneers are running out of oxygen. They need to find oxygen on Mercury, and fast.
No planet or moon found so far has a breathable atmosphere, and space missions can't carry more than a few months' oxygen supply with them. Permanent settlement will be impossible unless they can work out how to make oxygen from the materials they find around them. A crack team is right now working out how we could do this on Mercury's lookalike, the Moon. The Moon is covered in dusty dirt called regolith.
Although the surface appears to be very fine-grained as you get close to it. It's almost like a powder.
This powder is the result of the surface being smashed up by billions of micrometeorites, tiny rocks from space traveling at high speed. Mercury has come in for the same punishment, because it also has virtually no atmosphere to halt these miniature missiles. Day one on an experiment that could move forward space exploration by one giant leap. All eyes are on the world's biggest box of moon dust.
We have soil in here, it looks like sand, and the important thing is we know its density, we know its cohesion, we know it's how the dirt flows over the tool.
So this is the best stuff we've got on Earth to simulate what kind of dust there is on the moon.
This is the best stuff we have of this quantity today.
Moon dust is really bad news. It ruins equipment because it's so fine and abrasive. But when researchers analysed the dust, they were amazed. It contained lots of oxygen. This got scientists wondering, can we somehow harvest moon dust and then turn it into air that we can breathe? Diane's challenge is to plan the logistics of setting up an oxygen factory on the moon. Job one is to collect the dirt. It turns out digging on the moon isn't as easy as you might think.
On Earth, mass is no object. When you dig into the dirt, you need a reaction force. And so what they do on Earth is they give you a really big multi-ton excavation vehicle to resist the force of digging into the
But
dirt.
you're talking about Newton's third law, action and reaction. If I push down on the dirt pushes back on me.
Exactly.
You can't do that on the moon because there's less gravity. You just go up in the air.
This digging experiment is geared towards collecting the exact amount of moon dust a crew will need to survive there. Now that amount, how many times a day would you have to do that amount up?
We would need 2 of these loads a day.
2 of these loads a day, and how many astronauts could that sustain?
That's about what we would need for a permanent crew, 4 to 6 on the moon.
2 scoops like that every day could keep 4 to 6 astronauts with enough oxygen.
Yes.
That's amazing. Here's how it might work on Mercury. Twice a day, pioneers dig a load of regolith and tip it into a small chemical plant. NASA have proved that it works. They've made oxygen from rock in a test experiment on Hawaii. Digging dirt won't be the most exciting thing the Mercury settlers do, but it might be the most important. The pioneers now know that they can conquer the worst Mercury can throw at them. They enjoy Earth-like temperatures, a mobile habitat, water to drink, and now air to breathe. Of course, life won't be easy, but I've discovered the intense sunlight might not be all bad news. It offers the chance to